Unity allows us to build to a large number of different platforms, including Windows, Mac, Linux, consoles, mobile devices, VR. Pretty much any platform that can run a game probably has support in Unity. Now, with that comes a lot of extra baggage that Unity needs to take care of, and when you actually install your version of Unity, it doesn't actually give you all of that capability from the get-go. Instead, you need to add each individual platform which you need to build to as a module. Now, by default, you will have your default operating system already implemented. So right here, I'm on a Windows computer. So by default, I can build to Windows computers. The same goes if you're on a Mac. Now, inside of Unity Hub here, what we're going to do is go over to the Installs tab on the left-hand side here. And you can see my number of different Unity versions I have installed. I'm using Unity 2020 over here. And what we want to do is click on these three little dots here and go add modules. Now again, modules are basically the different build platforms that we can have, that we can then build to inside of Unity here. Now I've already installed Android build support here, which means I can actually build to Android devices. Now if you are wanting to build to Android devices, just enable this checkbox. Also make sure that inside this dropdown you also have these two checked as well. It is around 1 gigabyte in size, so depending on your internet speed, it can take some time. Now, if you are wanting to build to an iOS device, such as an iPhone or an iPad, then you want to enable iOS build support. Now, one thing that you need to keep in mind is that if you are on a Windows computer like I am, you're actually unable to build to an iOS device. Building to iOS devices is only possible on a Mac computer, so that is not possible. Although if you are on a Mac computer, you do have the options of building both to iOS and Android here, okay? So if you are on a Windows computer and you do want to build to an iOS device, unfortunately that's not really possible. You'll have to find a way to build this project on a Mac computer. So for me, I'm going to enable Android build support here. You can enable iOS build support if that's your case, but we're just going to do Android here for now. And then we can click done. Now I've already installed this before, so I can't install it again. So once it is finished installing, you should see that the icon for the corresponding module has appeared underneath your Unity installs version right here. I have a Android build support little fella right here. So now what we can do is just go over to our projects window here and create a brand new project inside of Unity. So I'm going to create a new project here. I'm going to call this one mobile game, and then we can click create to create a new project and open it up inside of Unity. Okay, here we are. I've got Unity open right here. Now, the first thing that we need to do is change our target platform inside of the editor itself. So at the top of the screen here, you can see we have the name of our project. We have the scene that we're currently in, which is just the default sample scene here. And then we have our target platform, or the platform that we are going to build for. And right now it is on PC, Mac, and Linux standalone, which basically means it's going to build to a computer. Okay, now what we want to do is change that to Android or iOS if you are on a Mac. So I'm going to go over to File right here, go Build Settings, and it's going to open up the Build Settings screen right here. Now at the top here, this is where we add our scenes to build. So I'm just going to click on Add Open Scenes, just at the start, just so in case we do forget later on, we have our scene here ready to build. And down at the bottom left is where we can change our platform. So right now you can see it's selected at PC, Mac, and Linux standalone. Now what I can do is then just select Android here and click Switch Platform at the bottom right. And what this is going to do is just change the editor around a tiny bit so that it has in mind, okay, we are building for an Android device, so it might have a few different changes based on some of the quality settings and various other things. And when we click build, it is going to build to an Android device. Now, it's very important to know that you can, of course, change build platforms anytime you want during your project. If you're building a game that is both on Android, iOS, and PC, you can of course switch between these platforms when you need to build it to that specific device. It may take some time depending on the size of your project. If you do have quite a lot of assets, quite a lot of scenes and data in your game, then it can take some time switching over to platforms, so keep that in mind. Although for this course, we're pretty much just going to stick to Android here since we're not really going to build this game for desktop, it's going to be for mobile only. And now our editor is set up and ready to go for Android game development. We can just exit out of this screen right here, and now we can begin. Welcome back everyone. In this lesson, we are just going to be creating a little basic project so that when we build it to our device, we have something to see and interact with. So right now inside of Unity here, we have our default scene with nothing in it whatsoever, except for our main camera and a directional light. So what we're going to do is go ahead and create a little platform, and then we're going to be placing objects on it so that in our game, once we build it to our device, we can tap on the screen to change whatever we are clicking on. Okay, so what I'm going to do is just right click on the hierarchy and create a new 3D cube right here. Let's position it at, let's say 0, 0, 0, so it's right in the middle here. We can then scale it up along the X to maybe 10 and 10. Oh, I guess we'll do 20 then. 20 on the X and 20 on the Z. Now we need our main camera to be in a position which is sort of overhead on an angle. So I'm going to select our main camera right here. I'm going to move it over here. Press E to go to the rotate tool. Rotate it like so. Maybe even rotate it down a bit so it's on an angle, sort of like an isometric angle, like so. We can then refine the rotations right here. So X, we're going to make this 45, and Y, we're going to make this negative 45. We'll go 11 on the X and negative 11 on the Z. If you look in the game view now, this is what it's going to look like. Let's maybe reduce the field of view a bit so it's not, so we see less depth. Bring this up a bit here. And I reckon for now, that's all right. That looks like an all right sort of platform where we can place objects on. So you may notice though that the ground looks a bit weird. It looks dark. We also have the edges here, which are in shadow, don't really look that good. They're pitch black shadows with not so bright surfaces. What we need to do here is enable auto generate lighting. And the reason for that is by default, we have real-time lighting on our directional light, which basically means that it is going to be updating the lighting and the shadows every single frame. And by default here, since auto generate lighting is off, it's not really doing that. So we need to go over to the bottom right corner of the screen here, and we need to select the auto generate lighting off button here. This is going to open up the lighting window, and all we want to do in here is go right down to the bottom of the screen and enable auto generate right here. And that is going to begin automatically generating our lighting. So we've got our lighting generating here. You can see it has a nice white surface. The shadows are looking good as well. And if you look in the game view, this is what we see. Now I'm going to right click in the project browser and create a brand new folder to store our materials in, as we are going to be creating a couple here. Let's right click, create a new material for the ground. And in the scene view, we can just drag and drop this on the object like so. And then in the inspector, we can modify its values to maybe be a sort of dark gray platform like that. Now, pretty much we just need to populate this with various different objects to be able to click on. Okay, so as a bit of a challenge, I want you to go ahead, create objects. These can be circles, squares, rectangles, pretty much any shapes you have. If you want to import your own models, you can. This is just going to be a platform for us to be able to click on inside the app, just to demonstrate that the touch inputs work and that we're able to render it to the screen. So go ahead, set that up, and I'll be right back to see how you're done. Okay, and here we go. As you can see, just a nice basic scene. Finally, what we can do is select our main camera and change the background color, because right now it is on a skybox, and let's just change it to a flat color. So over in our camera component, I'm going to select the clear flags and change that to be solid color. And then we can change the color here to be pretty much whatever we wish. I'm going to probably keep it something like a dark gray, a bit darker than our platform here. And there we go. So now in the next lesson, we are going to set it up so that we can actually start detecting touch inputs on our objects here. Okay, so I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to be setting it up so that we can detect touches on screen and then figure out what game object in our scene we are touching. If we're touching a game object, we're going to access its mesh renderer component and then change its material color to be a random material, okay? So let's go down to our project browser here. I'm going to create a brand new folder called scripts. I'm going to create a new C# script called touch manager, okay? And this is going to keep track of what we're currently touching on and then change the color of the object when we touch it. We need to attach this script to a game object in order for it to run inside of Unity. So let's create a new empty game object called underscore touch manager. I'm just going to set its position to be 000 just so it's consistent here, and drag on the script as a component like so. We can then double click on the script to open it up inside of Visual Studio. And inside of here, what we're going to do is first of all delete the start function since we won't be needing that. Now down here in the update function, every single frame we want to basically detect to see if we are clicking or touching on an object. Now that's going to take a few different steps in order to achieve that. First of all, we need to know whether or not there are actually any touches currently on screen at the current time. And to do that, we can go if input.touchCount is greater than 0. Touch count basically being the number of fingers or touches that are being registered on screen currently. If that's greater than 0, that means there are some touches on screen and we can then check those. Now in our case, we're not going to be checking every single touch on screen. You can of course do that with a loop if you wish, but in our case, we are only going to be checking the first touch on screen because realistically, you're only going to be using one finger with this little game or app. So what we need to do now is check to see if that touch that is on screen, is that touch on screen for the first frame? Is this the first frame that this finger is on screen? Because if it's not, we don't want to be changing the object's color every single frame that the finger is down on the screen for. We only want to change the color on the first frame that we are touching on an object. So for this, I'm going to enter in if input.touches in brackets 0 here, dot phase equals touch phase dot began. Now this may look confusing. There's a few things here that you probably don't know what's going on. All we need to keep in mind is the concept of arrays, and touches right here is an array of all the various different touches that are currently on screen. And an array is basically a variable which can contain multiple values. With a normal variable, it can contain one value, such as an integer, a float, a string. It contains one value. Whereas an array is basically like a cabinet. It can contain various different drawers, each with their own value inside of it. So let's just say you have an integer array or an int array, and you can have multiple integers inside of that array. So you could have maybe 5, 50, 200 inside this single array. And inside arrays, there are the concepts of elements and indexes. Elements are the individual variables inside of the array. So if you have an array of 5 different elements, that means you have 5 separate variables inside of this one array. And an index is basically how we can access these various different elements. An index is like an ID number for each element, starting at 0 and going up. So that is why here when we write down touches, we are accessing the touches array. So basically a cabinet drawer full of all the various different touches currently on screen. And we are accessing the 0 index, the 0 element, which is basically the first element in the array. So we're accessing basically the first touch on screen. And then what we are doing, we are getting the dot phase, and the phase is basically a description of what the touch is currently doing on screen. With touch phase here, there are a number of different ones. If we go touch phase dot, you'll see we have began, which is when the touch is on screen for the first frame. Cancelled is when the system has cancelled tracking the touch. Ended is when you have released it. Moved is when you have moved your finger, and stationary is if it's just standing still. So we want began because touch phase.began is active on the first frame that you are touching down on screen. And if this is true, if we are touching our finger down on screen for the first time, then what we want to do is figure out which object we are touching in our scene, okay? And to do this, we are going to be using something known as a raycast. And inside of Unity and many other game engines, raycasts are a very important and very useful concept. Think of it as a laser pointer. When you have a laser pointer, you aim it at something and you press the button to shoot the laser. And what this laser does is it goes from the position at which you are shooting it in the direction which you are aiming at, and it is going to hit the first object that it detects, that it touches. And that is basically a raycast. In Unity, we give it a position and a direction, and from there it shoots off in that direction, and it is going to give us information back on whatever it hit. In our case, we are wanting to shoot a raycast at the position of our finger in the direction of the camera, and we want to know what object it is going to hit, if it hit an object at all. Okay, so we need to do a few things here. First of all, I'm going to create a new variable called ray, and a ray inside of Unity is basically a container for a position and a direction. I'm going to call this one ray, and this is going to be equal to camera.main.screenPointToRay. Now, what this is, in order to actually shoot a raycast from our finger, we need to convert that to world coordinates, because inside of Unity, you have world coordinates, which is basically the equivalent of 1 meter to 1 Unity unit, whereas we have screen coordinates, whereas 1 unit in screen coordinates is equal to 1 pixel. So if we are touching on screen, that's going to be, a couple hundred on the X, couple hundred on the Y. It's going to be very far in world coordinates. So we need to convert this screen position to a world position in order to shoot a raycast. And that's what this function here does. We are accessing the main camera, and we are calling the screenPointToRay function here. And inside of here, we just need to give it a position of screen coordinates to convert to a raycast in world coordinates. So what we're going to do here is just give it the position of our input.touch. So I'm going to go input.touches in square brackets 0 to access the first touch dot position. Okay, and this gives us a position of our touch on screen. We are going to convert it then to world space, and then it's going to create a ray for that position and in the direction of the camera. This function here does it automatically for us, which is very nice. So we've got our ray now. Apart from this, we need something known as a raycast hit. Okay, and a raycast hit is an object that basically contains all of the information of what this ray has hit. So we'll create a raycast hit right here. We'll call it hit. It's going to be empty right now, but once we hit an object, we can check to see what we hit and then modify its components. Now finally down here, we can start shooting the actual raycast. And to do that, we want to go if physics.raycast. We need to give it the ray and then go out hit. Okay, so what this does is basically we are accessing the physics systems of Unity. We're telling it to shoot a raycast. We are giving it the ray, so we're giving it the position and the direction to shoot it at, and then we are outputting the information that it hit to this hit variable right here. Now, if this raycast was successful at firing, then this function will call. And inside of here, we need to make sure that we hit an object, okay? Because we don't want to try and modify an object's color if we didn't hit an object. So first of all, we need to go if hit.collider doesn't equal null. Okay, so if this object that we hit, if it hit its collider, then this if statement will be true. Null basically mean nothing or non-existent. So here we're basically saying, okay, did we hit a collider? If so, then this if statement will be true, and we can then run the code in here. Now what we want to do in here is start by basically creating a random color. And to do that, we can go color, I'm going to call this one color equals new color. And in here, we need to give it a red, green, and blue variable or value. Now this ranges from 0 to 1. So here I'm just going to go random.value, which gives us a random value between 0 and 1 for the R, random.value for the G, and random.value for the blue. Okay, and there we go. We've created ourselves a random color. And in order to modify this object, in order to modify its color, we can just go hit, which is going to access the raycast hit over here, which contains all of the information, dot collider to access the collision, the collider that this raycast hit, dot game object to access the object that this collider is attached to, dot get component, and then we want to get the mesh renderer component, which is basically manages all the rendering inside of Unity for that object. .material, we want to access the object's material. .color equals color. Okay, so we're making the object's material color equal this new color that we created over here. So that is the script for detecting touch inputs, then shooting a raycast at where we are touching on screen. And then if we hit an object, we're going to access its collider and access its mesh renderer and change its material color like so. Okay. Now in the next lesson, we are going to go over actually building this to a device so that we can then start testing it out to see if it actually works. So thank you for watching, and I'll see you all in the next lesson.